Good morning, everyone. We are very happy to be here. Our first FuturePrint, and so many interesting talks yesterday, today morning. And because we are so lesser known, I'll begin with some introduction on myself and my team. So I'm Madhu Kaushik, Senior VP CTO at Vera Inkjet. In my role, my principal role is to lead the company's research and innovation. In addition to that, I also participate or contribute towards company's strategy in business dev, manufacturing operations, and finance. So before I was in the print industry, I was doing my PhD. In my PhD, I did research on colloidal water-based suspensions of polymers, of nanomaterials, and I was using those for organic catalysis in green chemistry. So now I'm using the same water-based suspensions, polymers, for developing inks. So that's what circles back me to the print industry. I forgot about changing slide. So Vera Inkjet, what do we do? Vera Inkjet does research and innovation for water-based pigment inks and fluids for piezoelectric print heads. That's our core identity. We are based out of Montreal, so Mary and I here came a long way to be part of this awesome community. We love being here. Thank you for making us, Marcus, here, bringing us here. So in addition to research, we also have excellent manufacturing facilities. We have stringent control, stringent standard operating procedures, excellent quality assurance, quality control, which ensures you batch-to-batch consistency and high-quality products. The ink portfolio we have at present is for graphic inks, for textiles, and for packaging. And in addition to the inks, we also own our white. So white dispersion, pigment dispersion, we make our own, we own the technology. We are vertically integrated into that technology. What else? So inks, white dispersion, we can research, we can manufacture them, and it is all due to our team. We are a very small team, but we like ourselves to be called small and mighty. It's a diverse team, not like most of the companies here is full of traditional formulation chemists. None of us, when we joined the industry, were from that sector. We are a team of scientists who are doing polymer science, material science, mostly in water-based, and we learned inkjet and jetting on the work. So that's what we do. In this picture here, my CEO, Glenn Pearson, said, use this picture because I'm here with two of my teammates looking very happy, trying to see something about printing on the t-shirts. However, the truth is that we are usually frustrated, and not because water-based inkjet is challenging, and Montreal is usually filled with snow. So we are navigating the snow, and we're navigating the challenges of water-based. But water-based, as we saw yesterday, for most of our fellow speakers, that it's in demand. Over the past 2 decades, the demand for water-based inkjet has been increasing. And why so? The drivers are sustainability and regulatory compliance. We know water-based inks are inherently safe. But in addition to that, what has enabled water-based adaptation, the revolution, what has adapted, is engineering advancements, right? So there has been so many engineering advancements in the past decade on the print heads, on the printers, that it's possible. We also saw that most recent addition to this advancement is from ZAR, the Equinox print head. We contribute in this space. So Vera Inkjet believes that we can make a difference in the water-based inkjet inks and fluids by giving our expertise on the formulations. So that's where we are. So how many of you have been doing water-based inkjet formulations here?
No, we work with water-based.
Water-based. So you would appreciate that water-based inkjet formulation is challenging. Why? Because it is a multi-component, complex colloidal system. Also, the ones who are not doing water-based, they do appreciate that the water-based inkjet inks are still not there yet. There's a performance gap when we compare ourselves to analog printing. And even in the digital space, when we compare ourselves to UV printing, right? And that comes from the challenge because we depend on, for example, for adhesion, we depend on polymer, the binders. And these binders do not like to be in water. We are making them or forcing them to be in water for our use. Then the color comes from the pigment dispersions. They don't like to be in water, and these pigment dispersions are nanomaterials. So they actually want to agglomerate and sit outside of the water. And we are dispersing them in water. So these two things then gives rise to the complexity of making these water-based solutions ink stable and the shelf life. We don't want the sedimentation to occur. We need pigment dispersions to be stable. We need polymer chemistries to be stable and adhere to the substrate. And then there is the application part of the challenge, right? Like printing speeds are still not there. Why? Because we are water-based. The water just won't evaporate. So we can't reach the printing speeds of solvent-based inks or analog printing at present. And then because it is a new technology, it requires so much of innovation, the costs are high of these inks. So I and my team likes to separate these challenges of water-based into two major categories. One is the chemical performance and the other is the jetting performance. And if we have done water-based, this is our fight daily between the chemical and this. We are balancing contradictions. There's always a tug of war, right? So, and without going into so much science, because I promised Marcus that I will not speak about science, but still, so just to kind of appreciate the contradictions, for example, adhesion to the substrate. We would need a binder, a polymer, which would stick, and usually those polyacrylates or polyurethanes are high in molecular weight. But if it is high in molecular weight, most of the time they are not even jettable, and if they are jettable, they have high viscoelasticity. And that means that they're gonna not be a good candidate for a good drop formation. Because of the viscoelasticity, there will be a huge tail, it will split into multiple satellites, and you will not get an ideal drop formation. Similarly, we need fast drying times, but for the humectant package, which is good for the faster drying times, will not give you good enough open times. And the open that will affect the print head nozzle health. So these are the contradictions we always face. And how Vera approaches this is to address the chemistry first. So as I told you, right, we are not ink formulators. We are all chemists or engineers in the team, and we approach this problem by approaching the chemistry first. So over the last 7 years, what Vera Inkjet was doing back in Montreal, Canada, outside of the main hub of Inkjet, we were studying a lot of binders. We were developing a lot of polymer chemistry, which was ideally selected to be in the jetting limits. And then we went through evaluating a lot of pigment dispersions. The white dispersion technology is our own. We have it for textiles. We have something different for packaging. So we developed that. We have a toolbox of a lot of humectant packages which we can play with, which will give you fast drying speeds, but without compromising the open times in the print head. So that's what we did. We have a lot of surfactant packages. We have lots of additives, pinning agents, and it kinds of like now we have a chemistry toolkit, right? So what happens is a client comes to us, and we have already a chemistry toolkit where we will ask them, okay, do you like the chemistry performance? Do you now like the adherence? Do you like the wash? Do you like the rub resistance? And if once they approve that, then we go to the jetting part. It's not that we don't worry about jetting at all. We do worry. And we have a drop watcher. In fact, there are 2 drop watchers in all of Canada. One is owned by the Canadian Mint, and the other by Vera Inkjet. So we have an in-house expert. Over the past 3-4 years, we have really developed methodologies to use dropwatcher. It's a complex instrument, and just to get data and analyze and make sense of that data, that's the expertise we have developed. And when we kind of are in a stuck position in that sense in using the dropwatcher, we usually reach out to Mark Bale, our friend over here. He gives us some more help. So our chemistry is printhead agnostic. So once the client tells we want to jet this chemistry from this printhead, we move it to the dropwatcher, we see if it's good. There might be optimizations from the dropwatcher to the lab to the dropwatcher. So that's the second step. The third and the final step is applications in the real world, where we optimize everything in the real presses and real world. And it's a very collaborative effort from the client side versus our side. So today I'll showcase 3 examples. Although we have inks for graphics and textiles, and they're all commercial, best in the class, and we have some samples in the table open, and we'll be able to discuss more. I wanted to showcase something which is new. So water-based for packaging. The first sample here is on a non-porous substrate, like flexible packaging. And I have these right off, maybe in the coffee break, you can have a closer look. So this is a PET film, and we have developed, it has not been primed, it has not been corona treated, not been plasma treated. So without any treatments, we have printed the water-based white and the colors onto it. The challenge for these non-porous flexible packaging is adherence and wetting. Like the talk from yesterday, adherence, it comes from the binders, and wetting comes from proprietary surfactants. So that's what we use together to solve the problem for these flexible packaging. Of course, these are proof of concept. This is not a commercial product. We haven't, so right now we are working with machine builders, OEMs, and some of end user collaborators who are right now checking them in the real press, because they are like, okay, we don't like the print speeds. Of course, for water-based formulators, that's the first thing the real world applications tells us, is that they don't like the print speeds. So right now we are printing this at about 35 meters per minute. And they would like to go to 100 meters per minute. That's the target. But still a development phase, but very exciting. And we are very, I think we are sure and confident that in next few months we'll be able to achieve those speeds. The next is somewhere a little bit more forgiving substrate. It's a clay-coated news bag. Usually this substrate is used for enfolded carton and tag and label industry. And they use either analog printing on it, or if they're using inkjet ink, they will have an inkjet receptive coating. We are not using any inkjet receptive coating on these substrates. They are not being treated, and this is a novel ink binder technology which we have used, and it comes out dry. So the printing speeds are good, and we recently have an OEM who just approved it for their use, and actually it was being showcased in the Printing United last month by that OEM. Then the other substrate, the other example I have is from the porous substrates. These are corrugated boxes, crafts paper. Here the challenge is completely reverse of what we see in the flexible packaging, right? From being over there, adherence is a problem. Over here, penetration is a problem. We have such high pore sizes, such big pore sizes, and the ink just seeps in. And even like in the digital space, not only just water-based, even UV inks are facing problems of this penetration. So, but we have been, so these are primed, but now we have a newer ink technology where we can do something similar, not primed. It's way more in the lab stages rather than the proof of concept. But these are proof of concepts with primer, and we are able to print water-based ink onto highly porous substrates. Another example we really love to show, because we have reached out to industries in the shipping where they can do a label without using a white label, just printing right onto it. So these were a few examples which my lab was working over the last 1 year, and some of them are way more ahead in the technological level, some are really in the beginning stage. But just to summarize about Vera's approach, we are a small, mighty, passionate team, and that makes us or enables us to be customer-centric. So we will be able to adapt. We won't be giving you off-the-shelf product. If you have a water-based project or an application for which you need a water-based inks and fluids, we'll be able to help you with the development project. And also because we are so much focused about research, but people usually forget that we're also into manufacturing. So we can take your project from idea to industrialization. So we can not only just develop the ink for you, we can also manufacture that ink for you. We have a very flexible model in the revenue, and that lets us, because some of these packaging projects are huge, right? The ink consumption would be huge. And we don't have that capacity right now, and for that we are willing to collaborate with other bigger players in the field, other bigger ink manufacturers of the field. Collaboration is the key, right? So like in the previous talk, collaboration is required, and just because we are all ink manufacturers doesn't mean we have to compete with each other. In fact, we would like to collaborate. We're open to collaboration. So if you have a water-based project for which you need expertise on the water chemistry, we are here. Please come and talk to us. Thank you.